show you today, what I'm going to show you today are these half angle identities. So if we could flip to page 27. 27. Now, and I would have a unit circle out if I were you. So you guys, check out these new formulas. What is this saying? This is saying the sine of an angle alpha divided by 2. Because, correct me if I'm wrong, is 15 degrees on my unit circle? No. But is 30 divided by 2 is 30 on my unit circle? And is 30 divided by 2 the same as 15? So can I say, we're gonna do 14. Can I say that the cosine of 15 degrees is the same as the cosine of 30 over 2? 30 over 2 is just 15. So have I rewritten this with an alpha that is on my unit circle? My alpha, would you agree? Oh, I'm using cosine, my bad. My cosine formula, my alpha's right there. That alpha has to be on my unit circle, and it is. You cool with that, Brady? Cool. Now, check this out. Plus or minus. We're back to a plus or minus. Want. It's okay. Here's what you got to think. You know the angle that we chose. I'm sorry, cosine of 15 degrees. The original. What quadrant is 15 degrees going to be in? Right. So anywhere in that first quadrant, would you say the cosine, the x-coordinate, would be positive or negative? Do you agree? Anywhere on that first quadrant. So my answer is going to be the positive version of that square root. It's not going to be the negative. What if the original question was, hey, what's the cosine of 95 degrees? 95 degrees would be over here in that second quadrant. Turn it over, turn it off. Wouldn't the cosine anywhere in that second quadrant would be negative? Yeah, okay. What about the sine over in the second quadrant? What if this was the sine at 95 degrees? The y values would be positive there. So the hard thing about this plus or minus is it is not, you have to figure out which one it is from the original question. You're going to say, okay, 15 degrees is in that first quadrant, and the cosine, the x value would always be positive there. Now, you do not base it off of the alpha that you come up with. Okay, you don't base it off the alpha, you base it off the original question. Because what they're asking for right here is, what is the x-coordinate at 15 degrees? Cool, you guys are good. You guys, we're going to go use this one now. Boom, here we go. We're going to go use that cosine formula, and my alpha this time is 30. So we're going to say the cosine of 30 over 2 is the plus or minus, I'm sorry, but we said plus, of root 1 plus the cosine of what was our alpha? 30 over 2. Okay, here we go. Now we're going to go to our handy dandy unit circle. What is the cosine at 30? You agree with Philip? Root 3 over 2? All right, so we're saying, let me get me some new color here. We're saying, do I need to keep writing the positive square root? I don't. I just know that it's not negative. I'm cool with just leaving it as positive. We got the square root of 1 plus, Philip said, root 3 over 2 divided by 2. Now all we got to do is simplify. And I know that is way easier said than done, but we're going to do this together, people. Here's what I want y'all to do. Common denominators. Right here. 1 plus root 3 over 2 is the same as 2 tooths plus root 3 tooths.
It's going to be 2 root 3 over
2.
Oh, sorry.
Plus root 3 over 2. All divided by, instead of writing divided by 2, 2 is the same as 2 over 1. Right? 2 is not 2 over 2, that's 1. Okay, instead of writing divided by 2 right here, could I multiply by the reciprocal instead? Just to save myself a step? Instead of this big divided by 2 again, could I say that's the same as multiplying by 1/2? You okay with that? So if you want to write yourself a note, that came from right here. Bloop. Instead of dividing by 2, I multiplied by that half ski. Multiply straight across, y'all. Y'all are tuned in, and I appreciate this. Multiply straight across. We got a big old root still. 2 plus root 3. Do you agree? Because 2 plus root 3 times 1 is still 2 plus root 3? He said, yeah. What's on the bottom? Foe. I love it. You guys, you are going to maybe have a conniption over this final answer, but you're going to be okay with it. Check this out. Is this the same as root 2 plus root 3 over root 4. Can I break my big old root apart? Yes, I can. What is root 4? 2. Guess what? We're done.
No conniption.
Conniption because we've got a root in a root, but guess what? It's okay.
What does that mean?
Oh, a conniption is like you're going to go crazy. Let's look it up. So let me double check that my mode is in degrees. If I go type the cosine of 15 degrees, and then I type this madness of root 2 plus a root 3 in the root, all divided by 2, and we get the same thing. Why am I okay with a root and a root? Because that's fine. As long as my root's not in the denominator. We're good. Yeah? That was kind of funky, though. Let's back this up. We don't know what the cosine of 15 is on our unit circle, but we can use these formulas by putting them in terms of doubling your angle so that 30 over 2 was the same as 15. Now, we've also used the sum and difference identities before that we did, like 45 minus 30 was 15. That was what your last quiz was on. So this is just another formula. Again, I'm never going to make you memorize them. Let's try it one more time. We got this question over here. If I can move that unit circle. Tangent of 22.5 degrees is not on my unit circle. It's half of 45, right? Isn't 22.5 the same as 45 divided by 2? When you get the sum angle, you're like, dude, that's not my unit circle. Just double it, and boom, now you've got your new alpha. We're going to use this formula right up here.
Are you ever going to?
Okay, so you guys, think about this original question. 22.5 degrees is in which quadrant? First quadrant. 22.5 degrees is going to be somewhere over here. The tangent, the y over x, would be positive. Anything over there is positive over positive, so I don't have to worry about that negative root. Yeah? Okay, cool. So we got a positive root. You can write the positive. You don't have to. Just don't write the negative. Here's our formula. 1 minus the cosine of my alpha. What's my alpha here?
45.
Yeah, over 1 plus cosine of 45. We can't cancel those out because there's addition. Let's go simplify it. What is cosine at 45? The x value at 45 degrees, root 2 over 2. Root 2 over 2 divided by 1 plus the same x value, the cosine of 45, another root 2 over 2. Okay, here we go. What are we going to do first? Just focus on this. What do you do? Not quite yet.
Conjugate.
Condoms, denominators. Let's get those condoms. So you guys, this guy up top will be 2 tooths minus root 2 tooths. Over 2 tooths plus root 2 tooths. Yeah? Yeah, you guys, you always want to get those condoms. What do we have then on top?
2 minus root 2 over 2.
Yeah, you agree with that?
So many twos right now.
Hey, so many 2s right now. What do I have on the bottom?
2 plus root 2 over 2.
Yes. Does anything bless you? Bless you. Cancel.
Yeah, the 2 in the bottom.
Do you agree the denominators do? Because as you said, Sammy, you knew we were going to be multiplying by a reciprocal. If and when we did that, those 2s, one would be on the top and one would be on the bottom. Love it. What am I left with, y'all?
2 minus root 2 over 2 plus root 2.
With a big old root, right? Okay. So honestly, everything that you all said is going to be used. What did you say?
Conjugate.
Yeah, right here. Guys, imagine that this big old root's not here. Don't let that scare you. Don't you agree we've got a square root in the denominator and we got to multiply by the conjugate? He says, faux show conjugate. So I'm going to multiply by the conjugate. What is the conjugate there?
2 minus root 2.
You got it. It's just the denominator with the opposite symbol in between. I'm going to do that on the top and the bottom. Welcome back from spring break. Holy moly. Whew. Here we go. What is 2 times 2? 4. What about 2 times negative root 2?
Minus 2 root 2.
Minus 2 root 2. What about negative root 2 times a 2 again?
Minus 2 root 2.
Another minus 2 root 2? And then add to that negative root 2 times a negative root 2. Negative times a negative?
Plus 4.
Positive square root of 4.
Oh, so 2.
Very good. Positive 2. You're good.
I thought it was plus 4 too,
Yeah, that is a very common mistake. We cool with why it's not? Root 2 times root 2 will get me a 2. All right, let's talk about the bottom. Let's talk about the bottom. 2 times 2. What about 2 times negative root 2 versus 2 times positive root 2? They cancel out. That's what we get with the conjugate every time, and we love it. Ending with negative. Yes, Brady, you're a quick learner, buddy. Okay, so you're saying I just want to save time, and we got a 2 on the bottom. Agreed. What do we have on top, y'all? I still have that huge square root. Don't hate me for that. I apologize.
It's going to be 6
4 plus 2 is 6.
minus 4 root 2.
Beautiful. All over.
2.
Good.
And then you can start canceling out.
Yes. What am I going to cancel out?
It's going to be 3 minus 2 square roots.
6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1. And I'm left with root.
3 minus 2 root 2.
How many people would get there on their quiz and be like, I don't know if I did that right. But you're going to have your calculator. So we're going to go like this. Hey, what's the tan of 22.5 degrees? And is that the same as this insane root 3 minus 2 root 2? And I'm going to say, okay, I'm a little cooler than I thought. Whew. We're trying to verify these. Do you guys agree on that left side? I'd have no idea what to do.
Oh, just do cosine squared sin squared
Of these, I can't rewrite anything on the left side, but the cosine of 2a, could I rewrite it? I could. Now, notice I need to be left with, once we adjust to that right side, once we rewrite that right side, I want to be left with just a cosine minus sine. Does that make you want to use one of these more than another? The second one here? But do you agree that doesn't leave me? Oh, the second one listed down, not the second cosine one. Roger that. I got you. So Sammy's saying that one. Sammy, I like that one because you're like, dude, it's got the components. I get that it's square. It's too much, but I like that it's got the components. So Sammy, let's write it. That cosine of 2a we know is equivalent to cosine squared of a. We got to change my angle to a. Minus sine squared of a. All over cosine of a plus sine of a. Here we go. How could we, does anyone know how we could break this one down for, oh, we can't just cross out because we got plus and minus. Oh.
Oh, you're gonna cancel the bottom out.
Nope, can't do that.
Okay, well I think you can.
I would conjugate it.
How would I split this up? There's no square root.
cosine squared a minus sine squared a over cosine a.
Good job.
Nope, because nope, because this whole denominator needs to stay with both of them.
I have an idea.
You guys, I'm gonna have to eat my own robin egg.
Okay, Miss.
How would you factor this?
You boys. Oh, you're gonna use.
So what would this factor to?
Oh, cosine
Of
A
a
plus
plus,
sine of A multiplied by cosine of A minus sine of A.
Is that the same? If I were to distribute that back in, would I get what I started with? Cosine squared minus sine cosine plus sine cosine, they cancel. Welcome back, dude. Minus sine squared.
We're getting lit.
Yeah. So you guys, that was using difference of squares. Okay, you guys, now because that factors that way, So you guys, we just did difference of squares on the top. That's important to be able to factor that over the cosine of A plus the sine of A. Now can something cancel out?
Yes.
Now those can cancel out. So a lot of people on their quiz that I can't, maybe I passed it back already. You guys went from this and you just crossed things out. You can't do that. You have to factor it out. Yes, sir.
So you can't just like what I said. You just take out the bottom.
You can't.
Well,
It
it's
just,
quicker.
no, but that's, mathematically you can't do it that way. You have to show that the reason why they cancel out is this. You can't just cancel out. Nope. So if we're brainstorming, the right side, I could only do this, right? So the right side would be 2 sine of theta cosine of theta, and we need to turn it into that.
Let's do the left side.
So I hear what you're saying. Like, oh man, I could write that, and maybe we even still write it just so that we know it's over there. But do you agree, Margie? I don't know what else to do after that. 2 sine of theta cosine of theta. I don't know what else to do to turn it into this stuff. So Marge, I might leave it there, but I think I gotta go attack the left side now. What could we do on that left side? Saying, yeah, he's saying go distribute that out. So you guys, we got sine theta plus cosine. We got to do times sine theta plus cosine. And what would we do? We're going to distribute. Oh, don't forget about that -1 that was still hanging out there. Ooh, this is going to be good, y'all. This is going to be good. What's sine squared? Sine, oh, what's sine times sine?
Sine squared.
Sine squared. Plus
Plus sine cosine.
sine times cosine. Plus
Cosine sine.
cosine sine. Could I say it's the same as sine cosine? Agreed. Thanks, buddy. Plus
Cosine squared.
cosine squared.
I would like my gum.
Oh, you think I got gum on the line for just distributing that?
That's embarrassing.
You are not healed.
You are not healed.
Does that help, Dar? Don't forget I got to bring down, whoop, that -1. Boom. Braddock, I'm going to make you work for it. What is sine squared plus cosine squared, Braddy?
Sine.
Sine squared plus cosine squared is, you know, yes, it's just 1. So, Braddy, if that's 1, and what is 1 sine cosine plus 1 sine cosine? 2 sine cosines. Don't forget to bring that -1 still hanging out. Final answer. Right. He's saying those 1s are going to cancel out and I'm left with 2 sine cosine. Now, my girl Marge had us write something to start this problem out. What did Margie have us write on that right side? 2 sine cosines. We know if we go to our little formulas, we know on our little formula sheet, boom, that the sine 2 sine cosine is just the sine of 2 theta. So Margie, I think that was a good thing for us to write just because it kind of brought it to the front of our mind. And we did it. What do we do here? On the left side, I have no idea what I could do. But on that right side, could we do something there? Now, we got to think ahead though, people. We got to think ahead. Because cosine's got 3 options. Boom, boom, and boom.
I would say we only like cosine.
So you're saying that you want to keep cosines in it, no sines. Because you're saying this has no sines in it.
And we don't have a square. So it's got to be the second one.
So you're thinking the second one?
Absolutely.
He says, yeah, absolutely. Let's try it. So instead of writing cosine of 2x, we could say 2 cosine squared of x minus 1.
Yeah.
Yeah, okay, I dig it. Let's try it. Cosine of 2x, we're going to say 2 cosine squared of x minus 1. And then say that again, Curfy. Exactly. He's saying, dude, we got to bring down a -1 one more time. Agreed. And let me maybe put this way. This is that. Thanks, Curf Dog. Over. You're saying do what? We can. I'm going to show you. Let's think about something real fast. Let's just worry about the top. What does the top simplify to be? 2 cosine squared minus 2 over 2 from what we started with, 2 cosine of x plus 1. Does every term have a 2? Yeah, now, Margie, even if we distributed, every term still would have had a 2 and we could have canceled them out. You know what I'm saying? So that would have been totally fine. Sometimes we see it a little easier when the 2 is sitting out front. So everything has a 2. Would you guys agree we're left with cosine squared x minus 1 on top over a cosine of x plus 1? Now, you on your quizzes want to cancel things out. We can't do that. Do the exact same thing that I think Philip did for us the last time. Difference of squares up there. Or no, Graham did it for us. What is the square root of that? Cosine. Square root of 1? 1. What goes in between them?
Plus and minus.
Yes. On the bottom, we got a cosine of x plus 1. Now can things cancel?
Absolutely.
Boom, boom. Final answer?
I feel like this isn't hard if you know how to set everything up, but setting everything up is a little.
So here's what we're going to do. We're going to do page 29 and 30 is the homework on on 7-4. Practicing those formulas that I'll put up. Then I put a little 7-4 review on 31, 32, just if you wanted to practice those. The formative is on 33, 34. Formative is Black Day. Quiz on this is Friday. So that's the extra practice stuff that you've got.
Thursday.